Hello everyone, my name is Katie and welcome to the No Name Academy. These are some short videos on the new OWASP API Security Top 10. If you're already familiar with the OWASP API Security Top 10, you're probably familiar with quite a lot of these vulnerabilities already. You don't need to watch these in order, there's no particular order to them. Do feel free to skip around, especially as there's interesting additions and mergers, so if you are already familiar, then you don't have to watch all of them and then listen to information you already know. So API3, Broken Object Property Level Authorization. This is our second broken access control. So we have API1 and we have API3. And this is a merger of the mass assignment and information disclosure vulnerabilities from the previous OWASP Top 10. Again, when we see access control reflected in this new OWASP API Top 10, we're seeing three different types of access control at three different levels. So a bowler type is at the object level, and this is a broken object property level. This is at the individual property, so a property that an object has. So instead of talking about objects, we're talking about the properties of that object. So what does this look like? When developers start to design APIs, they'll often start with a very open API with everything being both visible and editable. It offers a lot of flexibility when designing to start broad and then remove what isn't necessary. For example, you might imagine an edit your profile form where you can change your username or your avatar, anything that comes under that API/users. But what about changing your password? When you have a password change form, you often need to provide your old password, and this is to stop the broken authentication from being able to change a password and commit a full account takeover. Now, the API may not force you to use this form and instead accept a password parameter into that edit a user resource, that put API/user/the user ID. It allows this user to change their password without confirmation. This is potentially could be weaponized in another vulnerability like cross-site scripting, or alternatively, it could also mean that the read for that particular request, the get API/user/32, that read endpoint, could also show the password field with the value in it. It's about that level of properties within a resource, within that individual resource. So what can an attacker do with this? It essentially allows an attacker to see or edit a field for a resource that they shouldn't. The final impact depends on the API. Like other authorization issues, it depends what you can do with it. The API is disclosing additional information that it shouldn't. It could be an account's password or credit card information, it's really severe, or it could be something else entirely. It could be a single property that maybe shouldn't be public, but actually being public, it's not going to break people's work. Or it could be the ability to bypass some security features, so things like password confirmations. I'm just checking the sound's working, yes it is. So why is this an API issue? APIs are often created from the final data storage rather than the business logic. They start out broad, they have this overly permissive parameters and overly permissive properties for flexibility in the development cycle, but they may not necessarily be removed, particularly for backwards compatibility reasons, where they may want to keep a property because it might be being used elsewhere. So how can you resolve it? So do use protections offered by your framework, such as the fillable/protected method, so where you define which properties are editable and which are not. Check that the properties that the API is returning is actually used in the final UI, and remove any parameters created via this flexibility before an application goes into production. Avoid leaving defaults from data storage, so just seeing exactly what's in the database and making sure that goes into the API. Don't write generic methods to automatically bind input to API resources. While this can save time and development, effort, it can lead to quite a lot of introduction of authorization issues in general. And don't not require password confirmation for any sensitive actions. If you're worried about these types of attacks, No Name can help. Its real-time protection can detect and block API attack with its real-time traffic analysis, while active testing allows you to test for API vulnerabilities in the development lifecycle before they're actually deployed. Thank you very much. That was API3 Broken Property Level Authorization.